students, welcome back. Now this video onward we will discuss the further part of machine. So let's start. Student, let's discuss the combination of the pulleys. Previously, single fixed pulley and single movable pulley we have discussed. Their maximum we will get MA2. But to lift the heavy load, we require the MA greater than 2. For that purpose, we require the combination of pulleys. We can do the combination in two ways. In the first way, you can use one fixed pulley and other movable pulleys. Or in the second case, you can use several pulleys together in two blocks, that is known as block and tackle system. In that, we are using fixed pulleys in the block and movable pulleys in the tackle. Now, let's discuss both the combinations in detail, students. Now, let's discuss the first combination of the pulleys. In this, one we are taking the fixed pulley and other are the movable. Just look at the figure. A, B, C, these three are the movable pulleys. Each are attached with a separate string. Each string has their own tension. All these three pulleys are attached with the fixed pulley, which is the D. Just look at the load. Okay, it is supported by two segments of the first string which has the tension T1. So your load is supported by two segments of T1. Now, when you look at the T1, it is again supported by two segments of T2. So your T1 is supported by two segments of T2. When you substitute in this, it will be 2T2. So till this, your load is 4T2. Now, T2 is again supported by two segments of the third string, that is T3. So, your T2 will be 2T3. So, when you substitute in this, it will be 2T3. So, your load till now is 8T3. But effort is only supported by one of the free end, that is T3. Now, when you want to calculate its mechanical advantage, you know that it is load upon effort. When you substitute the values, you will get like this. So, it is 8. It is the cube of 2. So, just look at the figure. I have taken 3 movable pulleys. So, I got 2 raised to 3. Same way, when you take the n number of pulleys, your MA will be 2 raised to n. Now, student, let's discuss the velocity ratio. Now, here in this case, suppose load is moved up by x meter at pulley A. Then B, it will be double, 2x. It will be 4x. So, till the effort, it will be 8x. Okay. So, now my displacement of load, if it is x meter, then my displacement of effort is 8x meter. And you know that it is displacement of effort upon displacement of load. So, it will be 8x by x, that is 8. So, you got it 2 raised to 3. So, this indicates that velocity ratio also in this case is 2 raised to n, where n indicates the number of movable pulleys. When you want to calculate the efficiency, you know it is MA by VR. So, you got 2 raised to 3 MA previously, VR also same. So, your efficiency is 1 or 100%. But in actual practice, due to frictions in the bearing of the pulley and weight of the pulley as well as the string, efficiency is never 100%. It is always less than 100%. Now student, let's discuss the second type, block and tackle system. In the block and tackle system, the upper one is considered as this one is the block and this part is tackle. Same way here it is block and this part is tackle. Now in the block, that is in the upper segment, the pulleys are the fixed one. While in the tackle, that is the lower segment, the pulleys are movable. Now, number of pulleys in the tackle is either equal to the number of the pulleys in the block, or just see in the second case, the number of pulleys in the tackle is one less than the number of pulleys in block. Now, let's discuss in detail. Now, when the number of pulleys in the block as well as tackle is same, how the string is moving? See, from the last block, that is last pulley of the block, to the first pulley of tackle. When you look at the load, it is supported by 1, 2, 3, 4 string. 4 segments of the string. So your load is 40, but effort, that is the free end, is supported by the one segment, so only the tension will be T. And you know that MA is load upon effort. So when you substitute these values, you will get it is as 4 only. Same way, when you look at the second figure, in that load is supported by 1, 2, 3, 4, 5 segments of the string. So load will be 5T, but effort at free end is only T. So your effort will be T. Same way, when you calculate the mechanical advantage, that is load upon effort, it will be phi T upon T, which is equals to 5. Now students, let's discuss the velocity ratio. Velocity ratio here depends upon the number of strands in tackle, okay, or you can say it is equal to the number of pulleys in the system. Now let's discuss that. In this first one, you know that there are 4 strands in the tackle. Number of pulleys also 4. So in this case, VR is 4. Same way here, there are 5 strings. So VR, based on that, it is 5. But 5 pulleys are also there. But when you calculate the efficiency, you know what is efficiency? Mechanical advantage upon velocity ratio. Now in this case, previously we got mechanical advantage 4, now velocity ratio 4. So my efficiency is 1. Same way here also efficiency 5 by 5. Previously we got mechanical advantage 5, 1. So 1 or 100%. But you know that is only in the ideal condition. Practically, there is friction in the bearing of the pulley. Okay. There is a weight of the pulley also. So MA is always less than the practical value. Whatever ideally we have calculated, suppose in this first case, MA we got 4, but practically it is less than 4, which results into the efficiency less than 1. Students, thanks for watching this video. Hope you have understood whatever I explained. Then also, if you have any doubt, put your comment. And if you are new to the channel, share and subscribe.